So I'm going to do a very quick revision, very quick revision, because I know that your time is precious. You have the exams next week. I'm going through the VLE note very quickly, but I'm not going to pay a lot of attention to the simple things. I'm going to pay more attention to the little bit complicated or something that you may have in it, or else at the same time, if you have any questions, you can ask while I'm explaining at any time. Okay, right. So the database indexing and tuning. So why we have indexing? Because we can speed up the query processing. But when you speed up the query processing, sometimes it can slow down your insert, update, delete text things, because you have to change multiple locations. So therefore we have to think about that also. Okay, right. Right, so these things I am not going to discuss, the memory hierarchy and other things that you can understand. Right, you are not kids now. Magnetic tape, hard disk, how hard disk work, but they will ask questions. Right, so then there are different type of files. The mainly heap file, sorted file, and hash file. Okay, B files are pretty much the index files. Okay, so what are the differences? Okay, so I'm not going to discuss about these things. SSD, solid state drives, you can read it. Right. So what is a data type record? You know these things. Right. And also there are two type of ways you can save your data records. Either fixed width. Fixed width means every record will take the same width, every record. But variable length means different records will be in different size. Right? The fixed width is easy to manage because we know that if I want to find the 15th record, that is 15th into that width that is where the record is. But it can waste storage. But when it comes to variable length, it is not wasting the storage, but you have to go by the file pointers to go to the next one, because it's not fixed width. It's not fixed width. If you want to find the 20th record, you don't know where is it. So therefore you have to just go by the end of record pointers to get the 20th record. Okay, so but usually the database systems prefer fixed width. Okay. Right. So then what is being by the blocking factor? Blocking factor is number of records that you can keep in one block. Remember, when it comes to a disk or SSD, the smallest unit is called block. So these blocks are loaded to the memory, right? So the smallest unit that you can load from disk or SSD is the block. You can't access smaller unit than that. Okay. So the blocking factor is number of records in a particular block. Always the block size is the same, right? So therefore, if they ask you the blocking factor, they will give you what is the size of the block and what is the size of one record. Or they will say it has 3 fields, name is this byte, ID is that byte, then you have to add it. Okay. And you know the size of the record. So the size of the block divided by size of a record is the blocking factor. Okay. And if they ask you to calculate unused space, because there are two type of ways you can put it: records, span and unspan. Span, unspan. Unspan, it means you don't keep half of the record in this block and the other half in that. So then that is unspan. Okay, so span means you can keep half of the record in one block and the rest of the same record in the other one. But usually it is unspan. So in unspan situation, you can have free space because you don't keep half of it. So how do you calculate the free space? If it is fixed with block size, the size of a block minus block factor into record, because that is the storage that take. Then the difference is the storage that we are not going to utilize. Okay, Right. I hope you can understand that. Right. So I explain you the span and unspan. Right. This is unspan. You don't keep half of it here and other half here, but here you can see it's span. You can see that the part of the record 4 is here, other part of the record 4 is here. That is span. But in the exams, usually for calculation, they will almost all the time assume unspan. Okay. Right. So we discussed that blocking factor. Right. So you will be giving these kind of questions. Okay. So I'm more interested in calculations. Say this question, the block size, that is the smallest unit of the storage is 256 byte. Right, 256 byte, and they say there are 50,000 records of students. So they have not given you the record size, rather they have given you the individual field size. So therefore record size is summation of 55 plus 2, 57, 58, 68, 68 plus 4 is 72. So therefore record size is 72 byte. Block size is 256. Now you can calculate the block factor, the number of records in the block, 256 divided by 72. And also make sure that you always floor it. 7.8 කියලා આવොත් ඔයා කියනවා 7යි කියලා. මොකද අපි ගන්නෙ unspan කියලා. ඒතකොට දශමටක් තියාගන්න බෑ. ඒතකොට අපි 7ක් තියාගෙන අර දශමට වෙනුවට එයා දානවා ඊළඟ එක. හරි? So that is how you calculate the block factor. Okay? Make sure you floor it. Okay? In this case, 256 is the block size, 72 byte is the one record size. So therefore, the block factor BFR is 3 records, because if you get 3 points something, you have to take it 3. Okay, I hope that is 100% clear. Right. Then the number of blocks needed, because now we know that in this case we can keep only 3 records in a block. 3 records in a block, and we know that there are 50,000 records. So that means how many blocks we need? We can keep only 3 records, and we have 50,000 records. So therefore 50,000 divided by 3. Right? In that case, you have to ceiling. Right? මොකද ඔයාට આવොත් එහෙම 5.8යි කියලා block 5.8ක් තියන්න බෑනේ, block 6කට යනවා. So then in that case, make sure it is ceiling. Okay, not floor. That is ceiling කරන්න. So that is not rocket science, right? That is very easy. Right. Right. So let's do another calculation. I think that you can do it now. Okay. So this same as pretty much the same question, similar question. So this you should be able to do it now. I'm just this very quick revision. Okay. I'm not going into details. Right. So then what are the file operations? We have the read operation. Sorry, we have the insert, update, delete, and select or retrieve. Other than retrieve, all the time it is a combination of read and write that we discuss in transaction handling. Okay, you read it, then you change that in the memory, you read the block. Okay, you do the change and you write the block back. That is how you do insert, update, and delete. Only when retrieve, you just have to read the relevant blocks. Again, relevant blocks. You can't access anything smaller than block, right? Right. So there are different file operations, but ultimately it's read and write operations. Okay. Right. File open, file close, file scan, etc. Okay. Find all, blah blah blah. And sometimes we reorganize. So there are different type of files. Okay. So static file means you are not allowed to modify once you read it. Dynamic files you can even update, delete, etc. Okay. Right. Then the type of files. So there are different type of files. This is very important. Examiner is going to ask questions on these things. Heap file means you are just adding the new records to the end. Right. So just new records. Whenever a new record comes, you add into the end. Add into the end means maybe this is the block now. You have to read that block, write add that record to the end and you write back. Now that record is also there. Next time again you read that block, add that record and put it there. Or you can just keep it in the memory if you keep on adding, right? So then once this block is filled, you go add it to the next block. So, but always you add it to the end, and there's no order, right? No order at all. You are just inserting it, or no sorting order, right? It's just the way you insert it, and it may not be in any order at all. So the advantage is insert is very fast. The disadvantage is all the other operations are extremely slow because no sorting order at all. Okay, extremely slow. This is mostly used for log files and things like that. Or if you just write it and without reading at all, or very rarely you read it. Right, that is heap file. Okay, right. So you have to go through these things. Okay, so how can you delete? Right, sometimes you can just, rather than deleting it, you can just mark it as a deleted record. Otherwise, you have to rearrange. Right, so then we have the ordered files or sorted file. In ordered file, we save the record in a sorting order. Right? So you can decide what is the sorted field. Usually, the sorted field will be sorting order field will be the primary key. Typically, very rarely it can be a different field as well. So then, of course, we call it secondary index, right? But usually it will be your primary key field. Okay. Right. So third type of files are called hash files. They are, you have different blocks. You have to calculate a hash value based on usually your primary key field. Then that hash value will decide which block it has to be saved. Maybe the next record will go to this block. Next record will go to that block. So it try to spread it as much as possible, right? Spread it as much as possible. First of all, it must have some idea about how many records you are going to have at the end. So then only you can decide what is your hash algorithm is, because you want to spread it as much as possible. Okay. So that is called hash file. And they are sorry. So they are the main advantages. All the operations are very fast. Insert, update, delete, everything is fast. Because the moment you calculate the hash value, you know which block the record is. Which block the record. You just have to load that record block. So then someone will ask why we are not using hashing all the time. Unfortunately, it is not sorted because your records are spread. If you are looking for individual records, once you insert, you are not going to get any reports or other things. So range, queries, etc. This is ideal. Hashing files are ideal. But if you frequently generate reports sorted by your key field, blah, 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 or your queries things where multiple records are coming as a result, so then hashing or hash files are not that good. Okay. Right. If you have any questions, you have to ask. Now you can see I'm now halfway because I don't want to take a lot of time from you guys, because we have, I think I explained this twice, right? I did this and again did a revision also because I knew that this is the toughest topic. Right. So then when it comes to hashing, there are two types of hashing, the internal hashing and the external hashing, right? So the internal hashing is very easy to understand, right? So you just have a hashing table with the hashing algorithm, like mod operation, etc. So using that, you decide, it will determine what is the block number is. Okay, block number is, then you have to go and save there. When you are retrieving also, when you are, since you are using the same hash function, it will give you the block number, then you have to go and retrieve the record from that block. Okay. And there are different methods, like mod function is there. Okay, folding is another hashing technique, internal hashing technique. Okay, where we can use the XO operation. I explained that in the class. If you are not very sure, you can refer to the recording. Okay. So then there's a possibility of collision, right? Whenever there's a hashing, there's a possibility of collision, because hashing is a big range is mapped to a small range. So there's always sort of inevitably the collision can be there. So there are two ways you can resolve collisions. Okay. What are those things? Actually, there are three ways: open addressing, chaining, and multiple hashing. So these are very easy questions, right? So if you get those kind of questions, make sure you get full marks. Right? Open addressing means basically if you find that that particular place is occupied, you keep looking for next vacant place and put it there, or next vacant block. So that is called open addressing. So when you're searching also, if you don't find it, you have to keep searching until you find it, or you find a vacant place. So vacant place is found means definitely that record is not there. Okay, because when you are inserting, it should have been inserted there at least. Okay, and in order to make it work, when you are deleting, you have to make sure that you don't delete the record and make it empty. Rather, you just mark it as a deleted. When you are inserting, if you see, when you're searching, if you see deletion mark, you still have to keep searching, right? Until you get a empty space. Okay, right? Chaining means if a particular block is filled, you chain it to another block and save it there, right? You chain it to another block at the end of the block, so that when you're searching for something, if you get it to the end of the block, there's a block pointer again deviating you to the next the next available block for that particular hash value. So that is called chaining. Multiple hashing means you use one hashing algorithm, and if you find that that block is full, then you apply the second hashing algorithm and see whether that gives you a space. Okay, so that is called multiple hashing. If second time also, if it is filled, you have to use one of these technique again, right? One of these techniques again, but at least you have two opportunities now, because we are using multiple hashing. Okay, right? So then we have the external hashing. So external hashing is, rather than just straight away calculate the hash value, we have now buckets, right? We have buckets. Okay, so that means set of blocks are considered as one bucket. That is the most important thing, right? Earlier your hash algorithm gives you a block number. Now your hash algorithm gives you the bucket number. Because your bucket has multiple blocks, the possibility of collision is less, right? Possibility of collision is less. That is the idea behind external hashing. Okay, it is not that you are going for external resource and calculate and blah blah blah. No, that is just a simple idea, right? So when your space is bigger, there's a lesser chance of collisions. So that is the idea. Okay, so rather than it gives you the block number, it gives you the bucket number. Okay. Right. So I'm not going to explain you everything, right? I'm just going to explain you the most important points only. Right. Now we are moving to the indexes. So indexes are the most important part, and sometimes the most confusing part as well. Especially when you are new to the subject, right? So of course we have done this subject for more than 5-6 years now, and we are pretty much familiar with the concepts. But you are learning this concept for the first time, most of you. So then it will take a little bit more time to absorb that concept. Okay. Right. So what is index? So index means you create another file, just like the book index. When you want to do a search, you first do the searching in the index file, which is a smaller file. Sometimes it will have lesser number of records, definitely lesser number of fields. For example, if your master record has 10 fields, your index file will have maximum 2 fields. So usually just 2 fields. right? So that is therefore the file is smaller because you have lesser field. Say 10 fields versus 2 field means smaller file. And not only that, in some cases, when your master file has 100,000 records, your index file has only 5,000 records. But that is not always the case. Sometimes. But in other cases, your master file when it has 100,000 record, your index file also has 100. In that case also, your file is smaller because less field. So the idea is first you do the search here and then you go to the master file, and sometimes you can straight away go and get the block number now. Okay. So searching in a smaller file is faster than searching in a bigger file. And also searching on a sorted file is faster than searching a non-sorted file. Right? If it is a primary key, usually this one is also sorted on that primary key field. But if it is a non-key field, this is definitely not sorted on that field unless you have a clustered index. Okay. So therefore, for non-key fields, having a index file is even more important than for a primary key field or the primary index. But anyway, primary index is also very useful because your index file is smaller than your master file. Right? So you must have very clear idea about this. Right? You must be 100% sure about that. Any questions on that? Any questions? Because you have only few days, right? Just 2 or 3 days, right? No, 4 days. Right? So if you have any questions, you can put it to the WhatsApp because I might be able to do another session on the Wednesday. Right? Maybe different topic. Okay, different topic, but I can take any questions that day also. Right. So I hope now you know what is the index and why we have index. But the disadvantage of index is when you are inserting, updating, deleting, not only you have to update to insert to this one, most of the time you have to, sometimes, not most of the time, you have to sometimes update your index files also. And of course, you can have multiple index files also. Then maybe when you are inserting a record, you have to insert it into maybe 3 index files and the master file. So it will slow down the process. But the idea is make search faster because it is the search that is most important. Because most of the time you go to your, you log into your bank online banking system and check your transactions. Right? So you are doing transaction lesser. Most of the time you go and search, right? You go and search. If you take something like examination results, most of the time people go and search results. Only once they insert and usually they don't update at all. Right? So we want to make search faster, right? For example, online catalog or something, we want to make sure that client feel good about the speed of the search. We can tolerate, internal people can tolerate a little bit of delay, but the client is mostly doing searching. Okay, so we want to make client happy, searching fast. Right. So this is very important slide. What are the types of indexes? So this is extremely important, right? Look at the big picture. So we can subdivide indexes into 2 types. Just give me 1 minute. Right. So we can identify 2 types of indexes, the single level indexes and multi-level indexes. So that is how you subdivide. Okay. That is the main categorization. These are the way we implement indexes. Okay. So therefore, this is our main categorization, single level indexes versus multi-level indexes. Your single level index can be primary index, secondary index, clustering index. Okay. Primary index, secondary index, or clustering index. So let's first discuss this. Forget about the other things. Okay. Right. So what is mean by primary index? Primary index means you index your master file, your data file based on primary key. Okay. So that is called primary index. Okay. Primary index. And we know that primary key is unique. You can't have the same value for more than one record. Okay. Right. So they are we physically ordered. It's very important. Right. Physically ordered by primary key. Right. Primary key. So your master file, your file where you have your employee details, your student details will be physically sorted by your primary key. If it is students, the student ID. Okay. So that is primary index. Actually, that is not the primary index. First of all, you will sort it based on the primary key, your master file. Then you can have another primary index file also. So don't get confused. Your master file is also sorted by primary key. At the same time, optionally, you can have an index file also. Index file also. In that index files, you have the primary key and the block number. That's it. Here you have primary key, your first name, last name, contact numbers, blah, 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 right? But here in the primary key index file, primary index file, you have the primary key and the block number. Primary key and the block number. Okay. And your master file is physically ordered by the primary key as well. Okay. Right. So that is the idea. So then definitely this width is smaller than actual width of a record. Right? Actual width of a record. So then someone will ask, what about the number of records? Yes, number of records can also be lesser. When this one has million, and maybe this one has only 10,000. Right? 10,000. Because now can someone tell me why? When this is 100,000, this can be 10,000. Because now your exam is almost closed. Can someone tell me why? When your master file has 100,000 records, how can your primary index file can have only 10,000 records? Because you can only have entries for the first record in that block. Say these are in blocks. Block. You can in the index file, primary index file, you can have only record for the first record of the block only. So then we assume that if it is 1 is here, 1,000 is here, 2,000 is here, we know that from 1 to 999, it is in this block number. From 1,000 to 1,999, it is this block number, something like that. Okay, so therefore we can even make it less short as well, right? Less number of records as well. So how do you call that kind of scenario? We call it sparse index. Neither. If you have, when we have 100,000 records here and in the index files also having 100,000, we say dense index. We can go for either dense index or sparse index. Primary keys, primary indexes, we can easily go for sparse index because sparse index is need less storage and faster retrieval. Okay. Right. So that is primary index. Right. Primary index. Then what is mean by a clustering index? Right. Clustering index. So clustering index can happen when your index field is a non-key field, right? Non-key field. Right? So in that case, we call it clustering index. It's not a primary key. It's a non-key field. Okay. So then, of course, when you have non-key field, there are additional complications are there. Okay. In that case also that your physical or the master file has to be sorted based on that field now. Right? If your clustering index field is say department number, now your master file will be sorted by department number rather than the employee number. Okay, and of course you are going to have the clustering index file as well. Right? Index file is also there. your master file is also sorted by that non-key field. Okay. For example, if you are frequently searching for department numbers, අපි නිතර ගන්න මේ department එකේ employees ලගේ report එකක් එහෙම, right? Or you search by department number. So then you may decide, okay, we are not going for the primary key index or primary index, we are going for a clustering index. It's very, very important. You cannot have both primary index and clustering index. You have to decide which one you want to go. Either go for primary index or clustering index, because you can't sort your master file by two fields. Either you sort it by primary key or you sort it by the other field, because one file you can't sort by two fields. Right? So therefore, it's a decision. Usually, you will go for primary index. Very rarely you go for clustering index, right? So you have to decide whether we go for primary index or whether we go for clustering index. Okay. And clustering indexes are mostly dense indexes, whereas primary indexes can be easily make sparse indexes. Okay. So it's very important. It cannot hold both primary index and clustering index at once. So this is very important point. Okay, you can't have both primary index and clustering index for a particular table or particular file. Okay, you have to decide one of those. Okay, right. But you can have any number of secondary indexes. That is fine. Right, file can have few secondary indexes addition to your primary index or clustering index. So you must have one of those and any number of secondary indexes. Okay. Right. When it comes to primary index file or primary index file, it has only two fields. That is your primary key field and block number. And again, it can be sparse index, because you can have only for the first record in the block only, you can keep it in the index file, because then you know that rest of the stuff before the next record is are also in the same block. Okay. So ordering key field and the pointer, the block pointer. Okay. Right. You can see that single level indexes, you can go for the only the field value of the first record, right? First record and the block pointer, right? Field first record's primary key value and the block pointer. So then it's a sparse index, because if there are 1,000 records per block, you have one record per 1,000 records. For every 1,000 record in the master file, you have one record in the index file. Okay, so that is good. So this is an example. Assume name is unique field. So this is address of the block 1, address of the block 2, block 3. For one block, one record. Okay, one block, one record, and this is the first record in that block. Okay, if you don't understand, you just have to ask. Now this is explaining that. You can see this is the first record of the block. This is the first record of the next block. First record of the next block. First record of the next block, next block, next block. If you have 1,000 blocks, you have only 1,000 records here. Okay, when it comes to primary index. So this is the master file, data file, and this is your primary index file. You can see simple L is less than capital L, and also the simple W is less than capital W. Right? So that is very important. This width is less than this width. This length is less than this length, and way less length. Right? That is how the single level primary indexes work. Okay. Right. So usually we can go for sparse index, right? You don't have to go for dense index when it comes to primary index. Okay. Primary index falls into the sparse or non-dense index type. Very, very, very important. Okay, very, very, very important. Primary indexes are sparse indexes. Right. So this is very important. Number of index entries are smaller than the number of records. Index entry hold two fields which are comparatively shorter than the master file record size, record length. Okay. Right. So what is the advantage of having an index file? Because your index file is sorted according to your primary key field. I mean the primary index file. You can do a binary search, right? Binary search. When you have sorted things, you can do binary search. When you have non-sorted things, you have no other option, go for linear search, right? So the linear search, the average access time is if you have n number of records, n divided by 2, right? But when it comes to binary search, it is log 2n, which is much more smaller value than this. Right? For example, if your n is 1024, here the average time is 1024 divided by 5, that is 2, 512. Here log 2024 is 10. So 512 access versus 10 access. But with 10 access, you are done. Right? You are done. Say you have 1024 blocks. 1024 blocks here on average you have to access 512 blocks, but when you have 1024 blocks, when you are doing binary search, on average you have to access only 10 blocks. Okay. Actually not on average, the worst case 10 blocks. Okay, this is the average case also. Worst case here actually 1024 blocks, but here the worst case also just 10 blocks. So that is something you must be very sure. That is what you learn in your data structures and algorithm topic in other subject. And once you find your block number in the primary index file, you have the block pointer. It's just a matter of going to that block and get it. So therefore you have to just read only one block from your data file, few blocks from the primary index file, exactly log 2n, and just one block because you have the block number now. Okay, so that is the idea. Single level primary indexes. Right, so we'll take a small break. After the break, we are going to do some calculations, as well as we are going to discuss how it is the calculations vary when it comes to clustering indexes and secondary indexes and multi-level indexes. Okay, so let's do this question. Single level index, primary index. This is primary index. But first we have to understand what kind of a question they give. First check whether it's a single level or multi-level. If it is single level, check whether it's a primary index or clustering index or secondary index. Okay, right, because those are three possibilities. Right, so this is a primary index question, and they say specifically unspanned, right? So they will always say unspanned because otherwise your question is going to be extremely complicated. Okay, let's say we have an unordered file with key field. File record are of fixed size, so they will always say fixed size and unspanned. That is, I'm pretty sure. Okay, following details are given, and we are going to calculate the block access required when performing a binary search. Okay, when performing a binary search. Right, so these are the details given. Number of records, 300,000 records are there. That means your data file has 300,000 records. Okay, and block size is 4096. So that means each block is 4096 byte. Record length is one record will take 100 byte. I hope you are sure, clear, 100 byte. So the first thing you can calculate is now the block factor. So block factor is number of records in the block. Right? Your block size is 4096. One record is 100. Therefore, number of records in a block or block factor is 4096 divided by 100, you have to floor it. And we get 40 records. Hope you are okay with that. Okay, right. So then they say, calculate the block access required when performing a binary search. Of course, we can do a binary search, right? So now we know that one block can have 40 records, right? One block can have 40 records. Then you have to calculate how many blocks are needed, because remember in our primary index file, one record per one block. So therefore, you have to calculate how many blocks are needed for the master file, right? 40 records in one block. We have 300,000 records. Therefore, number of blocks needed is 300,000 divided by 40. That is very straightforward, right? 300,000 divided by 40. That means we are going to have 7,500 blocks are needed for the data file, which will be sorted on the primary field. Okay. Right. So now we know that if there are 7,500 blocks, remember in primary index file, we go for one record per one block. That will be the first record of the block. So therefore, we are going to have in the index file, we are going to have 7,500. Okay. So this is, yeah. So this is without primary index. Sorry about that. If you without primary index, if you just go by the data file only, forget about the primary index. If you just go by data file, assume that it is sorted by the primary key field, but you don't have primary index file. Okay, you don't have the primary index file. Now we know that there are 7,500 blocks are needed. Right, 7,500 blocks are needed. So therefore, if you do a binary search, we know that the binary search, we always go to the middle, then half of that you can discard, then go to the middle of the selected portion, another half of that goes out, blah, blah, blah. So therefore, how many blocks we have to access? Log to 7,500. So log to 7,500 is roughly 13, because 2 to the power 10 is 1024. 2 to the power 11 is 2024 into 2, blah, blah, blah. So then next one, it is going to be 4,000, then 8,000. So it must be 13 because, okay. So that is number of block you have to access in order to locate a record is 13. Though we have 7,500 blocks for the master file, you don't have to access all 7,500 because already the data is sorted by the primary key. So then you just need 13 block access and you got the correct block. Remember, this is without primary index file, right? Just your data file is sorted based on primary key. Okay, primary key. Right. Now we are going to calculate what happens if we have primary key index or primary index. Okay, so the examiner will tell whether you have a primary index or you are just working on the primary file or the data file, which is sorted by the primary key. Okay, right. Now it is with the primary index file. Okay, now they are saying for the previous scenario given, if we have a primary index file, and now only it says if we have a primary index file with 9 bytes long or key value, because remember the primary index file is going to have only key value and the block pointer. Key value, block pointer. It says the key value is 9 byte and 6 byte block pointer. So that is one record is 15 byte. And how many records are we going to have? The number of records is same as number of blocks. And we found that we are having 7,500 blocks. So that means we are going to have 7,500 records, right? 7,500 records. Okay, so one record is 15 and we are going to have 7,500 such records, because one record per one block. That is the first record of that block. Now again, you can calculate the block factor. Block factor for the primary index file, right? Block factor for the primary index file is block size divided by the record size. Again, the block size is not going to be changed because it's something related to your disk. Your block size is, previously they have given block size is 4096. So therefore, your block factor for the primary index file is 4096 divided by 15. Right, 4096 divided by 15. You have to floor it because unspanned, and you will get 273 records per block. Because these records are smaller, the block factor is bigger. Your data file, the block factor is smaller, 40, because the records are bigger. But here, you can one block, you can keep more number of records, and more number of records. Right, now you have to calculate how many blocks are needed, because we are going to do binary search here now rather than the data file. How many blocks are needed? So one block you can keep 273 records. Altogether, we are going to have 750 records. So therefore, how many blocks are needed? 750 divided by 273. Right, 7,500, not 750, 7,500, because what we got is 7,500. So we need 7,500 divided by 273 blocks for the primary index file. So that means we have 28 blocks. Now we are going to do the search on the index file, primary index file, and we are going to get to directly go to the block data file. Okay, so therefore here now we are going to do binary search, right? So every time we eliminate half of the blocks, so therefore log 228, and then so we know that 2, 4, 8, 16, 32. Our next value is 32. Right? Remember, we have the ceiling. Right? We have to go to the up now. So the next value is 32. 32 is 2 to the power 0, 2 to the power 1, 2, 3, 4, 5, 2 to the power 5. So that means we have to have 5 block accesses, 5 block accesses. Then you get the block number. Block number. Now you have to go and get that block. So therefore we have to add 1. 5 plus 1 after 5 blocks. That is the worst case. In the worst case also, after 5 blocks you have the block number. Sometimes you can get it even earlier. This is the worst case. So in worst case also, 5 blocks you have the block number now. Now you need additional 1 block, because now we are going to go and access that block. Then in the memory you can filter the record. So therefore altogether you need 6 block access, which is improvement. If you don't have the primary index files, though you have your master file sorted by primary key field, there you needed how many access? There you needed 13 access without primary index file. But now we need only 6 block access. So that is more than 100% improvement, right? Less than half of the block accesses when we have the primary index file. Right? Any question on that? Any questions? Just let me know if you have any questions. No? Fine. So then we can go to the next. Okay. And I'm not going to explain the theory part, because theory part I explained in the class twice actually. Okay. I'm more interested in the calculations. Right. So now we are moving to now remember, you can have either primary index or clustering index. You can't have both. Now assume that we have decided to go for a clustering index. Say we are going to have a lot of frequent search on that non-key field, non-primary key field. Most of the time that will be either foreign key if you are frequently doing joins, or it can be another field if you are frequently doing search on that field. Assume that we are frequently doing search on an email address, not by the primary key field, because say students always come and say not their student number. They will say this is my email address. So then we are frequently search by email address rather than the student number. So then we can decide, okay, we'll go for clustering index. Let's not go for primary index. Okay. Right. So in that kind of situation, how to do the calculations or what is the concept? Now remember, this clustering index has two options. Either it can be a key field, maybe unique field, not a key field. Still, it can be a unique field. Like for example, let's say no two students can have same email address. Of course, email address is not the primary key, but still it's a unique field. Or it can be something like course ID, or if it is employees department ID, definitely it is not a key unique value there. Hundreds of employees in the same department, hundreds of students doing the same course, right? So there are two possibilities when it comes to clustering index: key or unique field clustered by on a unique field, or clustered by non-unique field. Right. Clustering index also contains two fields, one for the clustering field of the data file and the second one for the block pointer. That is obvious, right? So your clustering index file also going to have your clustering field and the block pointer, clustering field, block pointer, clustering field, block pointer. Okay. Right. Again, especially if it is unique field, you can just have the first record of the block. Right? First record of the block is enough. Right? Even when it is duplicate also, first record of the block is enough. Right? Even when the duplicate also. Right? But if it is unique, you are going to have more records. If it is not unique, you are going to have less records. Okay. Right. Right. Since the data file is ordered, entering and deleting records will cause problems. Yes, that problem is there. So when you are entering and deleting, sometimes, not sometimes, you have to insert in between, because it must be sorted, physically sorted by the clustering field now. And when you are deleting, again you have to reorganize, or else you just have to mark it as deleted. The easier thing is you just mark it as deleted. Then you don't have to reorganize. Otherwise, the records which were in the n+1 block may have to come to the nth block, because now we have additional space. So therefore, then you have to change your clustering index file also. So therefore, usually the easier thing is you just mark it. And maybe then and there, periodically you clean up your or rearrange your index files. Not all the time. Okay. If you are doing frequent deletions, you just mark it, and time to time you rearrange it. Okay. Right. Clustering index also falls into sparse index type. Yes. Since the index field contains entries for distinct values of the ordering key. Okay. Right. So this is an example for clustering index, okay, a non-key field. So you can see this is connected to this one, right? And second field is connected to again this one, same block. Why? Second field is also in that block. Third one is connected to this one, because third one is in this block. Right? Fourth one is connected to this block, because fourth ones are here. Okay. Now you can see that One is connected to the first block, second is connected to first block. But you can see some of the records having the value 2 because now it can be duplicated. Maybe it's a course number, maybe department number. Now these are linked. End of the first block will link to the next block. So then you have to look for, if it is not in, though this says first block, you have to look at in the first block, and if not, you have to go to the next one and check that also. As long as you have that number 2 is there, because you never know, it can be here or it can be in the subsequent one. But anyway, you can have just one entry. You can have just one entry as long as they are linked. They are linked. Okay. So therefore, again, it's a sparse index, right? Sparse index, not a dense index. You will have one record per one value. If we have 10 courses, and if you have decided to create a clustering index for the course ID, you will have only 5 entries. You will have only 5 entries, right? So therefore, in that case, it can be even more smaller than, or even smaller than the primary index file, because primary index file, each record has a, okay, or else, or we can say, yeah, we can't say it's even smaller because some, yeah, so it can be lesser because some, say if it is a department number, maybe the department number 1 records will be in the first block, second block, and third block. Then the department number 2 is in the fourth block. Then you have one, this one only says first block, the 2 says second, maybe 1 to third block. Yes. If you have 10 departments, you are going to have only 10 records, right? 10 records. So therefore, definitely, when it is non-duplicate, or sorry, when they are duplicate values, your clustering index file is going to have far less number of records. For the primary index file, the number of records is same as number of blocks. But for sparse, for clustering index, it can be even less than number of blocks, because one particular value might take up few blocks. In that case, all those blocks are represented by one record. Okay, because they are connected, linked. Any questions? Question right, now you should be able to do calculations based on that. Calculate concept, but you have cluster in field now. Again, you have 2 files. Your master file, it is physically now sorted by the clustering field, the non-key field like department number or a student email address, and of course you have the clustering index file. It may have even lesser number of records than number of blocks. Right, now let's do the calculation. Okay, clustering index single level. Okay, right, so let's read the question. For the same ordered file with number of records is 300,000, the block size is 4096. Let's say we have to use zip code, which is a non-key field, as the clustering field. Okay, to order the data file. Now the data file is going to be sorted by zip code, not by the primary key. So therefore, we are not going to have primary index now, right? Because it's physically sorted by zip code, your master file. Assumption: each zip code has equal number of records. Just an assumption. Okay, so that means if you have 100 zip codes, that means 300 divided by 100 number of records will be for one particular zip code. Just assume, right? Each zip code has same number of records. Okay, that is to make your life easier, right? To make your answer calculations easier. And there are 1000 distinct values of zip codes. So 1000 distinct values of zip codes means you can assume that each zip code will take up 300,000 divided by 1000. That is 300 records will be, every 300 record will be on a particular zip code. Anyway, that is not needed for the calculation, right? Right. So then index entries consist of 5-byte long zip code. So now look at the index entry. It has 5-byte zip code and then of course the block pointer, right? 5-byte zip code and 6-byte long block pointer. So that means 6 plus 5, one record is 11 byte. Right? One record in the clustering index file is 11 byte. 11 byte. Now you can calculate the block factor. Block factor means number of records in a block. Your block size is 4096. 4096 divided by 11. Right? You have to floor it. 372. 372 clustering index entries per block. Okay. Ek block ke clustering index entries 372 dan block. Okay. Now we have to calculate how many blocks are needed. Right? One entry, one block, you can have 372. Right? 372. And there are, remember, for each zip code, we are going to have one record. Right? Each zip code, we are going to have one record. So there are 1000 zip codes. So therefore, we are going to have 1000 records. 1000 records. So one block can keep 372. We have to have 1000 records because there are 1000 zip codes. So therefore, number of blocks needed is 1000 divided by 372. We have to seal it. And what you get is 3 blocks. So that means your clustering index file is going to have 3 blocks. Right? It's going to take up 3 blocks. Okay. Now we know that it is going to take up only 3 blocks. So therefore, now we are going to do the binary search. Now remember, we are going to search by the zip code. Right? We are going to search by the zip code. So it's going to take log 2, 3. So the next one is 4. Therefore, log 2, 3 is log 2, 4. 4 is 2 to the power 2. So therefore, it is going to take maximum 2 block entries. And 2 block entries plus 1, because then you have to go and access the data. So therefore, 2 plus 1, you are going to get, worst case, 3 block accesses. Right? 3 block accesses. Okay, so that plus 1 is not mentioned here. It has to be 2 and then you have the block number, go and access that. So therefore, it is going to be 2 plus 1, 3 block accesses and you are done. Now you can see it very fast. Very fast. Because of that clustering index. But now if you want to do search by the primary key, now you are in trouble. Because you don't have any index file. Your data file is also not sorted by that field. So then you have to do a linear search. So that is, if you have your data file has 1000 blocks, on average 500 blocks, worst case 1000 blocks you have to access. Okay, so that, yeah, that is the issue. This is the assumption that we are doing more and more search by zip code. Okay, right. So now we have done 2 types of indexes: the primary index, clustering index. You can have only one of those. You can't have 2, both. Right. So now we are moving to our third type, secondary index. You can have any number of secondary indexes. Okay. Any number of secondary indexes. Only thing is your secondary index field and your data file is having different sorting now. Your data file will may be sorted by either the primary key or the clustering field. But your secondary index file will be sorted by completely different field. Maybe you decided for primary index, so therefore your data file is index sorted by student number. Then you decide you are going to have secondary index, which is email address. Then that is sorted by the email address, your index file, your secondary index file. So that means you have the data file sorted by the, say, primary index, or so the primary key, student number. Then you may have the primary index file. Then you have the third index file, that is your secondary index file based on, say, email address. So 3 files: master file, primary index file, secondary index file. Okay. So you must not have any doubt about that. Right. A secondary index provides an additional medium for accessing the data file which already has a primary index, or maybe clustering index, right? Data file record can be ordered, not ordered, or hash. Even your data file can be not ordered as well. That means you don't have a primary index or clustering index. You are just going to have secondary index, which is very rare anyway. Okay. But your index file is going to be sorted by your secondary index file. Okay. Again, it can be a candidate key, which is then, of course, it is going to be unique, or it can be any other field. Then your secondary index field can have duplicate values. Okay. And again, your secondary index file is going to have the secondary index field and the block pointer. Secondary index field, block pointer, secondary index field, block pointer. Okay. So you can have any number of secondary index files as well. Okay. If your secondary index is a key field, sorry, not key field, say it's a unique field, then your index file is going to have one record, same number of records as your master file records. But if it is a duplicating, of course, your secondary index file is going to have less number of records. Okay. So that means if it is unique, dense index, otherwise you can go for sparse index. Right. So now you can see that since your data file is not sorted based on your secondary index, right? Your data file is not sorted based on your secondary index. You must have one-to-one mapping, because this is not sorted the way your index file. If there are 100,000 records here, your secondary index file is also going to have 100,000 records, because this is not sorted according to your field, because maybe it is sorted based on the primary key or the clustering field, or it's not sorted at all. Very rare that it is not sorted at all. Usually, at least you will be having a primary index. So this additional index. Okay. So you can see secondary index gives greater improvement in the search time for an arbitrary record. If you are searching by that secondary field, okay. Secondary index is more important because we have to do a linear search of the data file if there was no secondary index. Now remember, if you don't have primary index, still you can do a binary search on the data file as long as it is sorted by primary field, key field. If your data file is anyway sorted by your clustering field, even though you don't have clustering index file, still you can do a binary search. But when it comes secondary indexes, definitely your file is not sorted by your secondary index field. So therefore, this index file is extremely important. Otherwise, you have to do a linear search in the data file. Okay. So that doesn't mean that primary index is not important, but the secondary index is critical because if you go for the data file, you have to do a linear search otherwise. Right. Now let's take an example. Okay. Single level secondary index. Single level antima question work. Right. If we take the same example in the primary index, so that means the good old example, right? This is the third example. Assume we search for a non-ordering key field which has 9-byte log. Okay. A file with 300,000 records, fixed length of 100 bytes, and given block size is 4096. So those are the old data. Okay. Now again, we have to calculate the block factor of the data file. Right. So we have 4096 block size, one record is 100 byte. So therefore, block factor for the master file or data file is 4096 divided by 100. You have to floor it, 40 records per block. That means your master file is going to have 40 records. Right. So that is something else. Okay. 40 records per block. So therefore, how many blocks will be there? That is 40 records per block. We have 300,000 records. So therefore, number of blocks is 300,000 divided by 40 ceiling. 7,500 blocks are there. Okay. Now, if we do a linear search on that non-key field, assume that it is email address and email address is not the primary key, therefore no primary index. Assume email address is not our clustering field, therefore it is not sorted by email address anyway. In that case, if you don't have a secondary index, right, we have no other option but do a linear search, because we never know where this email address is. Maybe in the first block, maybe in the last block. So therefore, on average, 7,500 divided by 2 block access needed on average. But worst case is you may have to access all 7,500, and unfortunately the last block we had the data. Or else if you are looking for something which is not there, we can say that it is not there only after you search each and every block. So again, we have to access 7,500 block. So this is without secondary index. Okay, secondary index and okay. Now let's see what will happen if we have secondary index. Right. However, if we have secondary indexing, if you have a secondary indexing on that non-ordering key field, say it's a key field but non-ordering. Non-ordering means your master file is not ordered by that field, but it says it's a key field. That means unique. With entries for the block pointers, P equals 6 bytes long. Right? So your block pointer is 6 byte. Right? Block pointer is 6 byte. So then what is your field width? 9 byte. Non-ordering key field of 9 byte. Right? So therefore your block index entry is going to have 9 byte secondary index field plus block pointer size, which they have given it as, where is that? Block pointer. Yeah, block pointer is 6. So therefore 9 plus 6, 15 byte. One record is 15 byte for the secondary index file. And then what is the block factor? Blocking factor. Blocking factor is number of records per block. So the block size is as always 4096. which they have given. And one record is 15. Therefore, 4096 divided by 15, you have to floor it. 273 records per block. Right? 273 records per block. And remember, the secondary index is always a dense index. And the question says it is a non-ordering key field. If it is a key field, when we have 300,000 records, our index file is also going to have 300,000 records because it's non-key field. Sorry, key field. Key field means unique. Unique means you are going to have 300,000 different, say, email, 300,000 different email address. So therefore, our index file, secondary index file is also going to have 300,000 records now. So therefore, what is the number of blocks needed? 300,000 divided by 273. Right? We have 300,000 records. One block can have only 273. Therefore, we need 1099 blocks. Now, this time, so this index file is the biggest file because we are having unique records. Number of records in the master file and number of records in the secondary index file is the same. So therefore, number of blocks we needed is 1099. Anyway, it is lesser than the number of blocks needed for your master file, but still it's a big number because we have same number of entries as same number of records in the master file, right? But now it is sorted by that secondary index file. So therefore, we can do binary search. Binary search. So therefore, number of blocks needed for the worst case is log 2099. And of course, we have to ceiling. And we know that 1024 is there, 2 to the power 10. Then we have 2048, that is 11. So therefore, we have to go for 11 because this is more than 1024. So therefore, next one is 2048. Okay. So therefore, you need 11 block access if you do a binary search on that secondary index file. And plus, you have to go and access the record now. Right? So therefore, it will be 12 altogether. 11 plus 1, 12. Because what we get is the block number. So that block also you have access now. That is where your record is. And that block must be definitely having the record now. And therefore, you need altogether 12 blocks. That is how you do secondary index, single level secondary index questions. So you have to understand everything together. Okay, everything together. Okay, right. So this is sort of a summary. The primary index is a sparse index. Secondary index is a dense index. Right. So remember, primary index is sparse index, whereas secondary index is a dense index, especially when it is key field. Right, key field or unique field like email address. And secondary indexing is only logical ordering because your master file is not physically ordered anyway, right? Whereas primary or clustering index is physical ordering. So that is something you must understand, right? Right. So that's the end of the single field, single level. Single field, what we discussed so far is single level and single field also. Either it is student number or email address or maybe course number. One field indexes and one level indexes. So then there's another possibility. That what is that? Multi-level indexes. Assume that single field, still your index is just the, say, email address or just your primary key, your student number. But we are going to have rather than one big index file, we are going to have hierarchy of index files, right? Your level 1 index file. From there, you are send to the second level index file. This for this one, and here maybe you are taken to the data file or maybe another level of index. Maybe that index file is taking you to the data file. That is where you have the block point of the data. So then we say multi-level index files. Multi-level index files. Okay. So when we have so many entries for the index file, multi-level indexes are going to make it faster, especially for secondary indexes. Now remember, when you have a key field as a secondary index, remember in the your secondary index also needed 300,000 records and so much of blocks, especially for secondary indexes. Going for multi-level is handy. But if you have only few blocks needed for your index file, then no point going for multi-level indexes. But when we have so many index blocks needed, going for a multi-level index will speed up the process. Okay, speed up the process. Right. So how do you calculate the access time or access number of blocks access needed to get the record in case of a multi-level index? Again, first we have to check whether it is a primary index or clustering index or secondary index. Okay, because that will determine your first calculation, the number of blocks needed. Once you get to that, depending on whether primary index or secondary index or clustering index, then they will say this is the strategy for multi-level indexing. So then the rest of the calculation is common. But first thing you have to calculate how many blocks are needed for your index file. That is the starting point. And now they will say this number of spanning value is there. So then you can calculate the exact number of block access needed, and it is usually lesser than single level index. Okay. So lesser number of blocks accesses are needed than single level in general. Right. So when it comes to calculating this access time or number of block access needed, it's very important. There's a property called fan out. Fan out. So this fan out is the main concept that we use to calculate number of block access needed. Okay. It depends on the level. The level 1 fan out, level 2 fan out, level 3 fan out, and maybe that is the end of the level. Then you are going to the data block. Okay. Right. So let's do a in your note, they have not given you any example. So therefore, I highly think they will not give you a multi-level index question. They may most probably give you a primary index calculation, no second single level primary index or single level clustering index or single level secondary index question, because they have given you the formulas, but they have not given you any example. Right? But anyway, I'm going to do a question in case they ask. In case they ask, okay? Because you just have to use this formula. Right? Right. So I have that question separately. It will take only just another 2-3 minutes. Okay. Right. So these are the questions we did. Okay, these are the questions we did. Now this example 4, I will share this PDF version with you. These are the same questions. Okay, the examiner has put it into the PDF. This is originally taken from your reference book, right? Your reference book. Right. So we already did the example 1, 2. Right. Example 1 is without any index sorting or what index file. Example 2 is with primary index. Right. Then the clustering index, etc. Right. Now this one is if we have multi-level index. Okay. Multi-level index. So you have to go through first one, second one, third one. Anyway, these things we have already done. Okay. So therefore, you don't have to worry. Right. Now, this question says we are going to have multi-level index. Suppose that the dense secondary index. Now it says we are going to, I told you that usually multi-level index are used for secondary indexes because that is where you have same number of index entries as your master records, right? If you have 100,000 records in the master file, your secondary index file is also going to have 100,000 records. So that is where multi-level indexing is handy. When you have large number of records, that means large number of blocks needed. Okay, right. So it's the same question. Okay, not a new question, same question. It says example 3 is converted into multi-level index. Right? We calculate the index blocking factor. And there we found that you can have only 273 entries per block. 273 entries per block. Let's see whether it's exactly the same question that is given in your note. I hope so. Yes. Right, 273 entries, and we found that we need 1099 blocks, which is large number. Right, which is a large number. Right, same question. Okay. Right. Let's read it. Right. So we found that the block factor is 273 index entries per block, which is also fan out for the multi-level index. So for the multi-level index, that is called the fan out value. 273 index entries per block. Okay. The number of first level blocks is 1099 blocks was also calculated. So that is also be calculated, right? 1099. Right? We calculated that. The number of blocks required is 1099. So that is we have calculated. Okay. Previous question. Now the new question. Assuming that it's a secondary, we are going for a multi-level indexing now. The number of second level blocks needed is, because now we are going to break our index file into subfiles, right? How to calculate that? That will be 1099, that is number of blocks, divided by block factor for the index file. 1099 divided by 273, that is 5 blocks. Right? 5 blocks. That is level 1. Now you have to go for the level 2. Level 2, how do you calculate? This number divided by block factor. You have a ceiling. Of course, when you ceiling, you get 1 block. When you get 1 block, you stop. That means you don't have to go for a next level now. Okay. So that is the idea. If it is more than 1, again, we have to divide that by 273. That means we are going for another level. Okay. So that means we can stop at that time. That means at the third level, we can stop. The original level, that is first level, second level, third level we can stop because we have only one block. So then the number of access needed is number of levels. It's very important. Number of access needed is number of levels. Right? So therefore we have number of levels is, for this case, is 3 because there we got 1. And of course we have to go and access the data. So 3 plus 1, we just need 4 block access when we have multi-level accessing. And earlier we got, right? Or earlier we got that we needed how many? 12 block accesses, if not multi-level. But now we need only 4 block access when we go multi-level. So remember number of levels, because here to here, here to here, now go there. Number of level plus 1. Number of levels is 3 and plus 1, we just need 4 block access and we are done. If in case we have multi-level access, multi-level index in this secondary index. Usually you go for second multi-level when we have secondary indexes, or go secondary index, you need same number of records as your master file. Okay, right. So that's it. Right. Right. Now let's get back to your note and finish it. Now calculations are over. I did a additionally multi-level question also. I will be sharing that particular note at the end of the class. Okay. Right. So now you know single level as well as multi-level as well. And where to use multi-level? Usually for secondary indexes. Okay. And here you have to calculate how many levels are needed. You keep dividing by that number of records until you get 1, and you stop at that point and count how many times we did that. That is the number of levels. Right. So the next possibility is, now forget about the multi-level. Now just assume single level again. But there can be composite indexes. Composite index means your index field is not just one field, maybe 2 field or 3 field. For example, maybe you want to index not only by, say, department ID, but by something else also. Maybe department ID, salary, or course number, GPA. Both. What we need is a search which provide both GPA and the course number. For this course, which students got this particular GPA? Now it is that now we have 2 options. One option is, assume this is department ID and GPA. One option is you go for either index for department ID or you go for index by GPA, or you don't have anything. If you don't have anything, it's very time consuming because you have to do a linear search in the master file, or you just go for one index file, maybe secondary index for department ID, secondary or clustering. It doesn't, it depends on your requirement. Assume secondary index, you go for department ID, then you get all the records of that department ID. Maybe you are getting multiple blocks also. Then you have to, in the memory, you have to search for the GPA. Or if you go for secondary index by GPA, there can be so many students with that GPA value. Maybe department 1 students, department 2 students, maybe 10 department 1 students, 5 department 2 students, etc. Now again, sometimes you may have to get multiple blocks also, because so many students with that GPA. Again, you have to do that searching within in the memory. Maybe you have to read this block, that block, and find out whether your GPA and that department filtration is done. Or the better approach is go for a composite or multiple key index. You index by both department ID and GPA. So that is called Then you have department ID 1 GPA 1, department ID 1 GPA 2, blah blah blah. The department ID 2 GPA 1, department ID 2 GPA 2, blah blah blah. දෙකටම එකපාර sort කරන්න ඕන. Maybe first department ID then GPA, or first GPA then department ID. Again, it is determined by type of queries you are writing. Right. So when it comes to multiple key indexes, we need a mechanism to create that index. Or sometimes we call it composite index. So or multiple key index. Okay. Again, the first thing is, are we going for department ID, GPA, or GPA, department ID? That depends on the query that you are targeting to increase the efficiency. Okay. Right. So there are some techniques for multiple keys. So no calculation, just a simple theory. One is partition hashing. Right. Partition hashing. Partition hashing means, right, say we can give something like codes. Say department ID 1, say hash value is 0 1. Department ID 2, hash value is 1 0. So then the first part is department ID. Maybe the second part is GPA. Again, you have to decide 3 this value, 3.5 this value. Assume we are only going for one decimal point. So maybe this is 0.5. Right. So if it is 3.5 for different department IDs, always this part will be the same. If it is 3.6, yes, this is going to be changed. If it is a different department, this part is going to be changed. So therefore, by looking at this value, and if you know where the separation is, you know what is the department ID, what is the GPA. Okay. So that is called partition hashing. Okay. Advantages, disadvantages, I am not going to explain right now because it's a note. Okay. I shared this highlighted note to the WhatsApp group. Okay. Today also. Right. So another approach is grid files. Grid files. So in grid file, we have two-dimensional arrangement. Say this is department 0, 1, 2, 3. This is GPA. Maybe GPA 0, GPA 1, GPA 2, GPA 3. Or maybe GPA between 0 to 1, 1 to 2, 2 to 3, etc. So then your record will be one of these cells. If you are looking for department 1, that is 1, and GPA greater than 3, that is this portion. If you are looking for department 3, that is this, and GPA 1 and 1.9, that is 1, right? So that is this area. So all the records in this area. So that is called grid files. Grid files. Right. So that is, those are two approaches when it comes to composite indexes, implementing composite indexes. Okay. Right. So now that is also done. Now we are just going to discuss about how can we implement technically indexing, technically at the file level. Now the important part is over. Now a bit of technical thing. Right. We can implement index in different way. One approach is as a hash index. Another approach is as a bitmap index. Okay, bitmap index. Those are the two main approaches. Then you can have function-based indexes, and yeah, so those are the three types: hash indexes, bitmap indexes, and function-based indexes. Right. What is mean by hash index? So hash index means we are using a hash value, hash function. Say I have primary index. Right? Primary index, say my primary key value will be the input to the hash function, and hash function will say this is where your record is. Your record must be in this block. Okay. So that is called hash index. Hash index is not that good if you are doing range searches, etc. Or if you are going to take reports order by that. But if you are going to do individual searches, maybe student having this email address. Okay. That means you are not going to get multiple records as a result of the search. Hashing index is ideal if that is your main usage scenario, because it's very fast. You just give it to the hash function and it says this is the bucket or this is the block. But when you searches gives you range of values, and sometimes you want to order by sort by that particular field and get reports, this is terrible. Hash index is terrible because your one is here, 2 is there, 3 is there, 4 is there, 5 is there, because hash is always try to make it randomized, right? Try to distribute it randomly. So that is a disadvantage of hash index. But if you are going to search individual things, individual records, you are going to get as the search result. Most of the time, hash index is ideal. But if you are going to get ranges, maybe if your index fields is in department ID, so many employees with that department ID are there. And then we can go for bitmap indexes. Okay. And it is good for multiple keys also. Right? Multiple keys also, that is good. The bitmap indexes. Okay. Right. So this is an example of a bitmap index. Now you can see that you have male and female field. Right. So look at how it is done. Say there are, in this example, there are 1, 2, 3, 8 records are there. And assume that we want to index by gender. And gender can have only male or female. So now what we can do is we can create an index file. We can give it a code like male is this, female is 0. Male, now this is 1. Here female means male 0. Male means male 1. Now what you can do is you can keep this column as a file in a file. So that means if you have 1,000 records, you have 1,000 bits. Say 1 0 0 1 1 0 1 1, like 1,000 bits, because we have 1,000 records. So then by looking at this particular bitmap, say I'm interested in the 500 record, whether it's male or female, you have to go and see the 500 record and see whether it is 1 or 0. If it is 1, we know it is male, if this is the male bitmap index. And if it is 0, we know that that is not a male. Okay. So that is another type of implementing an index, bitmap index, especially for this kind of where you have only few number of possible values, maybe male or female, or maybe marks, grading, A, B, C, F. So bitmap indexes are going to be handy. So fail, pass, fail, or some predefined values. Right. So then you have the function-based index. If you have in the query, you do some function like upper, lower, sum, etc. You can incorporate that function also to your index, so that your search is going to be even faster. So that is very special case. Right? If you're taking a report and that report has that function, you can incorporate that function also to when you are creating the index. So then at the query time, already your index is has already done that, applied that function. So then the query is going to be faster. But I'm explaining it very fast because I have explained this twice in the class. Okay. Right. So now, then of course, you must know how to create indexes using SQL. SQL, it is very easy, right? Create index. Right. You can either say unique index or normal index because you know that sometimes there are non-unique indexes like department ID. But it can be unique index if it is something like email address, right? Index name, you have to give a name, then on table name, then column name, one or many column name, and the order with the ascending or descending. Okay. So then what is mean by tuning indexes? So remember, there are three reasons for indexing. Maybe you are indexing by primary key because frequently we search by primary key. So then definitely you are going to have primary index. Or maybe frequently search by another field. Frequently search by another field. So then we can make it either clustering index or secondary index. Maybe you are frequently searched by email address, frequently searched by salary. Or else that field can be frequently used for joining. Frequently we join by department ID. So either it is primary key, obviously you have primary index, or if it is in the where clause, where email address is blah, 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 or it is used for joining. So those are the three possibilities: primary key, or if not primary key, either you have it in the where clause of a frequent search, or it is in a joining. So therefore, most of the time, foreign keys are index. Sort of a by default index. Whenever you create a primary key, your database is going to create a primary index by default. Whenever you mark a foreign key, your database is by default creating a index, right? Because when you have foreign key, usually you join through the foreign key. But if it is something that you have a frequent search or reporting something, then you have to manually create it, because by default your primary index and the foreign key index will be created by most of the databases. And if you want to fine tune it, you have to decide, you can specify whether it should be using bitmap tree, bitmap index, or any other function based index or hash index, etc. You can specify those things. So only advanced users will do that. Others will just say create an index. But those who know these concepts, of course, now you know these concepts. Now you can go to the database and say, create this index. Make sure you use the hash index. Make sure you use the bitmap index. So that facility is there. Okay. Right. So that is called tuning the index. You decide, okay, no, bitmap index is not going to work. Let's create hash index. Okay, clustering index is not going to work. So let remove the clustering index and let's have the primary index and let's create a secondary index. So that is depending on the performance issues, etc. We have to decide that, and sometimes we have to experiment and see which one is the better one. Right. So that is called tuning indexes. Right. I hope now you have. I did a sort of a complete revision of that subject. Okay, that subject. That topic. Okay, right. So we are going to stop at this point. Maybe Wednesday, if you have any preferred topic, just let me know. Otherwise, I might decide the topic, or maybe I will decide, okay, that is enough now. Okay. Okay, we'll stop at this point. Thank you.